Welcome to the video for Lecture 14, Section 3. This video will cover solenoids. Solenoids are electromechanical devices that convert electrical energy into simple mechanical motion. The motion can be linear or rotary. The linear motion can be either a push motion or a pull motion. Solenoids can be separate devices that provide the motions listed, or they can be incorporated into other devices. In many cases, solenoids are part of the electromechanical relays we talked about in the previous video. Solenoids are also part of the solenoid valves I will talk about in the next video. So you can find solenoids by themselves or part of other devices. Solenoids have a coil, plunger, and the stop with a frame. The coil can be electrically charged or de-energized. When the coil is energized, it creates a magnetic field that attracts the plunger and pushes the plunger and anything attached to the plunger towards the stop. When the coil is de-energized, the magnetic field disappears and the attraction between the coil and the plunger is removed. The plunger can return to its de-energized position because of a load or load attracted to the plunger, or because of gravity if the solenoid is mounted vertically. There are several characteristics that need to be considered when selecting a solenoid. One is specifying the amount of force that the solenoid needs to generate in the energized state to implement the motion and action you want. The relation between solenoid force generated and the stroke length of the plunger is usually nonlinear. As stroke length or plunger distance traveled increases, the force available decreases. Suppliers typically give you tables like the one shown in the slide that give the force available for different stroke distances. Previously, I mentioned that gravity can help return the plunger to its de-energized position if the solenoid is mounted vertically. So it is very important to consider solenoid orientation with respect to gravity when determining the amount of force needed. You need to check if the suppliers gave you the gravity value. Another thing to avoid when selecting solenoid is to avoid purchasing excess force. If the solenoid coil generates excess force, the continuous hammering of the stop and the frame leads to premature failure. Additional solenoid characteristics that need to be considered include the amount of electrical input power needed to drive the solenoid. Suppliers will specify the coil resistance, watt, and amps required. As we discussed with relays, solenoids may have a duty cycle limit also, which limits the amount of time that the coil can be energized. An energized coils will produce heat, and heat reduces stroke force. So coil heating can be another important characteristic to consider if the coil will be used in warm or hot areas. Coil insulation levels impact the heating too. Similar to the discussion about relays, solenoid response time when energizing, which is called the pickup time, and when de-energizing, the drop-out time, can be important in some processes. Other things to consider include the solenoid dimensions, cost, and mounting positions. So far as I talked about linear solenoids, they are rotary solenoids that produce a rotary motion. The rotary motion is commonly created by adding spiral grooves for the plunger to move through the create rotary motion. Here is a list of rotary solenoid characteristics to consider when selecting one. With the linear solenoid, one of the characteristics was the force required. With rotary solenoid, it is torque. With rotary solenoid, the rotation angle required and the direction need to be specified. The rest of the characteristics are similar to those discussed with the linear solenoid. So this brings me to the end of lecture 14, section 3 video. The next video will cover solenoid valves. Please write down any questions you have and bring them up in the class or lab. Thank you.